Well, hello, Math 1. All right, so here's our ground rules for today. We're going to look over very quickly the two slides from yesterday, and then I have three more word problems for us to do. And then there are going to be four more other problems that you probably already see posted on a Google Doc. So you can follow along with me as I do these word problems, or you can do them on your own. It's your choice. However, you do need to show me all of your steps so I know what you were thinking and how you arrived at the right answer. Okay, so we'll jump right into what we were doing yesterday, which we've been learning about the quadratic function, and we've been learning about particularly how this is used for objects that are in motion and projectiles and things that travel in an arc. And so we read, first of all, how Marcus hit the baseball with an initial velocity of 70 feet per second. He made contact with the baseball bat when it was 3 equation to represent this. So if you remember, we said it was y equals, and then a negative 16 is the constant for gravity that we use in these types of equations. So negative 16x squared plus the initial velocity of 70 feet per second, so that's 70x, plus 3, which is the starting point because he was 3 feet above the ground. So his starting point is 3. So that was our equation. And then the next thing we looked at was at what time will the baseball reach its maximum height? And we determined that was 2.19 seconds based off of using what we know about the axis of symmetry. And then what is the maximum height of the ball, which we determined that's going to be 79.56 feet, again, based on taking what we knew about our axis of symmetry in the x value and substituting that back into our function. And then finally, where will the ball hit the ground? We used our quadratic formula to come up with 2.19 that the ball would hit 4.42. We came up with 4.42 in that block, which is where 4.42 seconds is where the ball was going to hit the ground. After 4.42 seconds of travel. Okay, so that was the first thing that we had gone over, and then we did on our own for those who wanted to, and then I showed you how to do these quadratic functions and using the quadratic formula. So let's go to this slide here, number 3, and we're going to again start where we left off yesterday with again writing a function and using the quadratic formula to find these different answers for objects that are in motion. Okay, so let's read our scenario here. It says a model rocket is launched straight up from the top of a 24-foot tall building with an initial speed of 90 feet per second. So the first block is using the information provided above to write a function to represent the height y of the rocket x seconds after it is launched. So again, we start off with y equals, okay? And since we're dealing with gravity here, it's going to be the negative 16x squared again. And the velocity is 92 feet per second, so plus 92x. And then its starting point, it begins 24 feet above ground on the top of the building, so we're going to have plus 24. So that is the function that we're going to be using to solve the different problems here. Okay, so the next block says, when does the rocket reach its maximum height? So the word when implies time. So if we're looking for time, we're looking for x. So what we're going to do is use the formula that I taught you before for finding the axis of symmetry. All right, so to find the axis of symmetry, I would go over here, and I'm going to say x equals negative b over 2a. So in this particular function, my b value is going to be 92. And then I have the number 2, and then my a value is 16, and that's a negative b over 2a. So I have a negative 92 divided by a negative 32. And when I do that math on my calculator, I come up with 2.88 if I round to the 100th. So what that tells me then is that when is the rocket going to reach its maximum height? It will reach its maximum height at 2.88 seconds. That is when the rocket will reach its maximum height. Now, the next question then is, what is the maximum height of the model rocket? So when we're looking at the what, we're looking for the y value, which is the height. So we're going to have here y equals, that is y, negative 16x squared plus 92x plus 24. So what I'm going to do is take the time of 2.88, which is x, and substitute it back into this function. So that's going to be y equals a negative 16 times 2.88 squared plus 92 times the 2.88 plus 24. So as I do these different calculations on my calculator, 2.88 squared becomes 8.29. And then if I do my 92 times 2.88, that gives me 264.96 plus 24. So if I finish multiplying that, I have y equals a negative 132.71 plus the 264.96 plus 24. And when I add up on my calculator, I get an answer of y equals 156 and 25 hundredths. So the maximum height of the rocket is going to be 156 and 2,500 feet. That's going to be the maximum height of the rocket. The final question then is, when will the rocket hit the ground? When will the rocket hit the ground? So in order to find out when will the rocket hit the ground, I need to find out the x's or the zeros of my function, but is going to be ground zero when it hits the ground. So to do that, to take a function such as negative 16x squared plus 92x plus 24 and to try to factor that is a little difficult. So then use instead is my quadratic formula that we learned yesterday. All right, so if I start with my quadratic formula, the basic formula itself is going to be negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Okay, so that there's my quadratic formula. So when I start substituting my numbers in here, all right, I'm going to have a negative 92 plus or minus, because that's my b value, the square root of 92 squared minus 4 times a negative 16, which is my a value, and then c value is going to be 24. And then all of that divided by 2 times a negative 16. So as I begin to work this out, I come up with a negative 92 plus or minus. So I do what's in my radical first. So 92 squared becomes 8,000 464. Then when I do 4 times a negative 16 times 24, that comes out to minus a negative 1,536. And then all of that's going to be divided by a negative 32. Now we know that two negatives make a positive, so this actually becomes a negative 92 plus or minus the square root of 8,464 plus 1,536. All of that divided by a negative 32. All right, so I made a little mistake there. It's the negative 30 divided by negative 23. All right, so when I get to this point, the square root of 10,000, which is 1,536 plus 8,464, the square root of 10,000 is 100. So what I do here then is I remember from yesterday that I said these are two equations. These are two equations because of the plus or minus operation. So one equation is going to be a negative 92 plus 100 divided by a negative 32. And then I'm going to have a negative 92 minus 100. All of that divided by a negative 32 as well. And so when I do these calculations on my calculator, I'm going to pause and give you a chance to do those at home. So my solution here is going to be a negative 0.25. And then my solution here is going to be 6. So I know, just from what I know about a parabola, that these two numbers are going to be the negative 0.25 and the positive 6 are going to be my starting point and ending point of my curve, and that my parabola opens downward because I have a negative x value. So the parabola is going to look something like this. So over here is my negative 25 hundredths. And then over here, this point is going to be is where 6 is. So I can conclude that this rocket is going to hit the ground at 6 seconds. So the rocket hit the ground at 6 seconds. All right, so that's the first one. Okay, so we've seen how we can use parabolas for projectiles motion. So we're going to move on now and see how a parabola can be used for production and manufacturing. All right, so here's my next slide. It says a manufacturer of light fixtures has a daily production cost of y equals 25 hundredths x squared, 25 hundredths times x squared, minus 8x plus 80, where y is the total cost and x is the number of units produced. So how much does it cost to produce 5 units? Okay, well, if we're looking at how much it costs to produce 5 units, we are simply going to substitute 5 into the function every place we see x. So what we're going to do then is, if we look at our basic function, which is y equals 0.25 times x squared minus 8x plus 80. all I'm going to do here is just simply put the 5 every place I have an x. All right, so what we have here is y equals 46.25. So if we go back to answer our question here, the question is how much does it cost to produce 5 units? So to produce 5 units, it's going to be $46.25. That is the cost to produce 5 units. So the next question says how many units should be produced every day to yield a minimum cost? So if you look at this again, my value or my coefficient of x squared is positive, which means this parabola opens upward. So since the parabola opens upward, instead of having a maximum like I do when the parabola opens down, I now am dealing with a minimum because the parabola opens upward. Okay? So it says here, how many units should be produced every day to yield a minimum cost, and then what is the minimum cost? So x is the units that should be produced. So I am looking at the x value of my minimum. So to find the x value of my minimum, I am simply going to use x equals negative b over 2a, what I've been using to find my axis of symmetry. So in this case, x is going to equal, if I look here, my b value is a negative 8, so I have a negative 8 over 2 times my a, which is 0.25. So 2 negatives make a positive, so x becomes x equals 8 divided by, and 2 times 25 hundredths is going to be 0.5. And so in this case, 8 divided by 0.5 equals 16. Okay, that's 8 divided by 0.5, not 8 times 0.5. All right, so I have an x value of 16. So what that tells me then is where it says how many units should be produced every day to yield a minimum cost. X is my cost value. X represents cost, or the number of units, X is the number of units produced. Okay, so if I'm looking at my number of units produced, then that's going to be X. So now the next thing says, what is the minimum cost? Well, again, since I'm looking for a minimum, I know my X value of this point right here. So now I need to find the Y value. So the way I find my Y value is I take 16 and I substitute that back into the function. So let's go ahead and do that. So our function is y equals so every place I see an x now, I'm going to substitute 16. So y equals 25 hundredths times 16 squared minus 8 times 16 plus 80. Okay. So when I do this math, I get, and so 16 squared is 256 minus 128 plus 80. So 25 hundredths times 256 is going to give me 64 minus 128 plus 80. All right, so I came up with y equals 16. All right, so what I just found there is my minimum point. So I need to produce to yield the minimum cost would be 16 units and units produced each day. And the minimum cost of producing 16 units is going to be $16. All right, so that just worked out that it's a 1-for-1. So the next one, or the last problem, says, how much more would it cost to produce only 5 units compared to the minimum cost? So to produce 5 units is $46.25. All right, minus the cost for minimum units, which is 16. That gives me $30.25. So my answer is $30.25. So it would cost $30.25 more to produce only 5 units as compared to the minimum cost of $16 for 16 units. Okay? And so to get a good idea just of what this parabola actually looks like, I'm going to go over here to Desmos. And we'll type y equals all right, now this one, because 80 is my starting point, this one is going to be way up here. So let me zoom out a little. So here we go. This is what it looks like. This is what this production curve looks like. So there's the minimum that we found, and this is what our production curve looks like. Okay, so for the final word problem today, and applying what we've learned about parabolas so far and quadratic functions, it says here the value of Jennifer's stock portfolio is given by the function y equals 3x squared minus 15x plus 50, where y is the value of the portfolio in hundreds of dollars and x is the time in years. So how much money does her portfolio begin with? All right, well, like I've already mentioned to you, the starting point is always your C value right here. That is your starting point. It is your y-intercept. Okay, your y-intercept is always your starting point. So how much money does a portfolio begin with? It begins with $50 because that's your starting point. Now, same thing here. It says after how many years will she reach the minimum amount? Okay, so again, this is a positive coefficient of x squared. So that means it's opening upwards. So this time again, we're looking for a minimum value. Okay, we're looking for a minimum value right here and what that ordered pair is going to be. So where it says after how many years will she reach the minimum amount, all right, x is the time in years. So again, I'm first looking for my x value, which means I'm going to use what I already know about finding x, which is going to be x equals a negative b over 2a. All right, so x equals a negative b over 2a. So if I go back to my function, my b value here is a negative 15, and the a value is 3. So x is going to equal a negative 15 over 2 times 3. So 2 negatives make a positive, so that becomes x equals 15, and then 2 times 3 is 6. So 15 divided by 6, if I do that on my calculator, becomes 2.5. Okay, so now remember, when we look here at 2.5, we were finding time in years. So after how many years we reach the minimum amount? So we're going to write here 2.5 years. Or 2.5 years, she'll reach the minimum amount. Okay, so my x value here for this ordered pair is going to be 2.5. Now I'm looking for the y. What is the minimum amount her portfolio drops to? So now I'm looking for that dollar figure, or for what is y going to be when x is 2.5, or how much money is she going to have after 2.5 years based upon this model. So here's what we'll do. We will go over here, y equals 3x squared minus 15x plus 50. So we're using the 2.5 that we already solved for. We're trying to figure out what is going to be that value of y when x is 2.5. So So 15 times 2.5 is 37.5. Okay, do all this math on your calculator, you get a number of 31.25. So when I apply some meaning to that based upon my scenario, it's going to be $31.25, because that's what I discovered here in my math problem, is that after 2.5 years, okay, she's going to have $31.25. That's her minimum values right there. So same thing, her maximum, or where she started, she started here at 50. That was the starting point on her y-intercept. And then she's going to go down, and then she's going to eventually turn around and gain money again. So after 2.5 years, she has $31.25. So the final part says to graph the function using Desmos, then answer the following questions. All right, so let's go over here to Desmos. And what I will do is show you how to graph this. Which you probably already know, but I'll do it for you anyway. So 3x to 6, 3x squared minus 15x plus 50. Okay, so here's what the graph looks like. And so there are some questions here that we need to answer. So here's the parabola. So as you notice here, 50 is 50. There's that y-intercept that we talked about, the starting point. Okay, so the first question is, after how many years will Jennifer reach the amount of money she started with? So she started with 50. So if I look over here, here's where she is at 50 again. So I'm going to have to zoom out a little bit, or zoom in to try to get a value for that. So here's 50. If I read down, still not too clear. Let me zoom it again. All right, so here's 5. So let's drag and let's read up. And it looks like right here, 50 intersects right at 5 years. So for my answer over here, where it says after how many years till she reaches what she started with, we're going to put here 5 years. All right. And then after how many years will she double her money? So I can go and read this off my graph. So initially she had $50, which means if she doubles 50, that's going to be 100. So let me just move my graph. And then here I am at $100 right over here. So like I showed you before, you can just click on there and it gives you an idea. So it says 7.29, and that's where she's going to have the 100. So of course, these are approximations. All right. So what I would just probably come over here and write for my answer then is, after how many years will she double her money? I would say approximately 7.5. Because it was 7.29, so I would just round up to 7.5. All right, so that is our lesson for today. So please go to the problems that I have for you on the Google Doc. It's using the quadratic formula again. And please submit your completed slides along with that, with the scan of your work in completing that document. All right, have a good day, and I will talk to you again tomorrow.